Namaste and welcome. Today, we're going to tackle a huge topic, something that's basically the backbone of our entire digital world, distributed systems. Now, I know, it sounds super technical, right? But trust me, it's the invisible magic that powers almost everything you do online. So let's dive in and see what's really going on behind the scenes.
So, let me ask you something. What do you think Netflix, your online banking app, and, well, the entire internet have in common? I mean, you're streaming a movie, you're checking your bank balance, you're just browsing a website. They seem like totally different things, don't they? But they're all built on the very same fundamental idea. What do you think it is?
You got it. They are all distributed systems. It's this incredible, invisible architecture that makes our hyper-connected world, well, work. So the big question is, what exactly is a distributed system?
Okay, let's break this down, because the official definition has two really important bits. The first part is a collection of independent computers. Simple enough, right? Just a bunch of separate machines. But the second part, that's where the magic happens. It says they appear as a single coherent system. What that means is all those different computers have to work together so perfectly, so seamlessly, that when you use the service, it just feels like you're interacting with one single powerful thing.
You know, to really get a handle on this, let's use an analogy. It makes everything clearer. Think of a single, standalone computer. It's kind of like a small, local business operating out of just one office. Everything it needs is right there, under one roof. It's all very simple and self-contained. Okay, but now, imagine that business becomes a huge success. It starts expanding, and suddenly, it's a massive global company with offices all over the world. See, each of those offices can work on its own, but they're all collaborating, all working under the same company banner to serve customers everywhere. That is a perfect picture of a distributed system. It's like a global digital enterprise.
So if you're going to run this massive global company, you can't just wing it, right? You need a solid plan, a blueprint for how you're going to grow and succeed. And for a distributed system, that blueprint is all about its key design goals.
And just like any growing company, our distributed system faces some big challenges. First up is size scalability. How do you add more and more users, more resources, without the whole thing grinding to a halt? Then there's geographical scalability. What happens when your offices, your computers, are spread across continents? The sheer distance can cause serious communication delays. And finally, there's administrative scalability. This is a tricky one. How do you manage a system that crosses different organizational boundaries, maybe even different companies, each with their own set of rules? All right, so to tackle those challenges, any good distributed system is built on three guiding principles. Think of them as the company's core values. First is transparency. The idea here is to hide all that complexity. A customer shouldn't care if the request is being handled in Mumbai or in California. It should just feel like they're dealing with one unified company. Next is openness. This means everyone agrees to play by the same rules, using standard protocols. It's like having standard operating procedures for every office, so they can all work together without confusion. And finally, of course, scalability. The whole system has to be built from the ground up to handle growth without collapsing into chaos. Now, not all global companies are structured the same way, are they? Some are very specialized, others are built on partnerships. It's the same with distributed systems. They come in different business models, you could say, each one designed for a very specific job. Let's check out a few of the most common structures. First, you've got cluster computing. The best way to think of this is like one super efficient department in our company. All the computers are basically identical, they're all in the same location, and they work together on one specific task. Then you have grid computing. This is more like a massive joint venture. Imagine different organizations, say universities all over the world, pooling their computing resources to work on a single, incredibly complex problem, like analyzing astronomical data. And then there's something called pervasive systems. This one is all around us. Think of a smart home where your lights, your thermostat, your speakers, all these tiny little devices are constantly talking to each other in the background to create a seamless experience for you. Okay, so every company needs an org chart, doesn't it? It's the map that shows who's in charge, who reports to whom, and how decisions and information are supposed to flow. Well, in the world of distributed systems, that org chart has a name. It's called the system architecture. And really, there are two fundamental ways to draw this org chart. On one hand, you've got the classic client-server model. This is your traditional top-down company.
There's a big central headquarters, that's the server, which has all the data and power, and then you have all the branch offices, the clients, who have to ask the headquarters for everything they need. But on the other hand, you have the peer-to-peer or P2P model. This is a completely different philosophy. It's like a network of equal partners. There is no central boss. Every node is equal, and they all share resources and talk directly to each other. So we've got our company structure, our org chart, but that chart is just a piece of paper if the different offices can't actually talk to each other, right? For any work to get done, there needs to be a communication strategy. So let's look at how these different parts of the system actually communicate. One popular way is something called a remote procedure call, or RPC for short. The best analogy for this is a direct phone call. Imagine you need information from another office. You think of the phone, you dial their number, you ask your question, and then you wait. You are stuck on that line, you can't do anything else until you get your answer. It's very direct, it's immediate, but it's also blocking. We call this synchronous communication. Now, the alternative to that is a model called message-oriented middleware, or MOM. And if RPC is a phone call, then MOM is like sending a company-wide memo or an email. You just write your message, you send it out to a general mailbox or a distribution list, and then you get back to your own work. You don't need to know who's going to read it or even if they're in the office right now. It's completely indirect, much more flexible, and we call this asynchronous communication. All right, let's take a step back and pull all of these ideas together. As we've seen, you can really think of a distributed system as a huge, modern, global enterprise built out of software. So, what are the key takeaways? First, the definition. It's like a global company with many offices that all act as one. Simple. Then, the goals. The company's mission is to be transparent to its customers, open in its standards, and scalable for growth. We saw different types or business models, from highly focused teams like clusters to collaborative joint ventures like grids. We looked at the architectures. The org chart. Is it a top-down client-server model or a flat peer-to-peer network? And finally, we saw how they communicate, either with a direct, synchronous phone call like RPC or an indirect, asynchronous memo system like MOM. And that really brings us to the future, doesn't it? The world is getting more and more connected every single day. The services we rely on are becoming mind-bogglingly large and complex. Think about the Internet of Things with billions of devices, or massive global AI models. The demands we're placing on these systems are just growing exponentially. So the question I want to leave you with is this: what new challenges will the next generation of distributed systems have to solve? What comes next? Thanks for watching, and see you in the next session of this series.